Hey guys, in this video I wanted to discuss an idea that I like to call open domain mathematics. It's basically founded on a really simple assumption, but it has all kinds of implications for how we talk about different set theories and how they relate to each other. And the idea is just this. So even though sometimes we talk about the domain of, say, a logical theory like CFC being only the objects constructed by the axioms of CFC, actually what we want to develop a set theory for is to talk about all of mathematics. And set theories really can also be viewed as having a universal domain. If not in the sense, I'm not talking about a set of all sets, but we can. One of the main purposes of a set theory is, of course, to talk about sets of any kind of mathematical object. Now, why is this important? Well, it entails that actually commitment to a set theory is a lot different than commitment to a typical mathematical theory. There's ways in which set theories can be applied to each other. There's ways in which set theories can give models of how mathematics in general works. For example, each set theory will give a different model theory, and so we'll have different implications about how logic works. Each set theory gives a different theory of decision in second-order logic, so it has different philosophical implications and implications about the notion of truth. Each set theory might, if you're a mathematical proceduralist, a viewpoint I'll discuss in another video that I'm coming up with, you might say that each set theory actually defines ranks and orders of computation. And there may actually be multiple different ways of getting set theories to talk to each other. We could potentially, try to use tools like forcing to see how different set theories interrelate to each other. And normally this might not matter, but if we are doing open domain mathematics where we hold that basically the domain of any given set theory should actually be promiscuous, and that committing to a set theory should actually be committing to all logical implications of it, not just inside of the set theory, but in all of mathematics, then we have a new way of mapping mathematical territories. Basically, I'm not against at all the idea of a mathematical multiverse, but the really interesting thing we're going to be getting if we're doing open domain mathematics is we're going to be finding that perhaps not all regions of the mathematical multiverse work well together. So, yeah. And in other videos, I'll give some examples of this, why I'm suspicious of the fact, since I think commitment to a set theory actually is different than commitment to, say, like Euclidean and non-Euclidean geometry, where you can have geometries that give completely opposite results, but they don't map over the same domain, so there's no competition. I'll give examples of why I'm suspicious that we can accept CFC and new foundations at the same time.